Welcome to Cherry Hill Tuition, where incredible results are achieved. In this mathematics tutorial, I will cover some of the excellent processes used by Cherry Hill to achieve the highest grades. Let's get started. Before we start with the questions, let's go over some background theory. When we are working out an angle in a right angle triangle and we have been given two sides, there is a rule that we need to remember. SOHCAHTOA. I will go through this now. So let's look at the first triangle. We have been given the hypotenuse and the opposite, and we need to work out theta. Now, because we've been given the opposite and the hypotenuse, we have to use sine. So the reason we use sine is because it involves the opposite and hypotenuse here. This means that sine theta is equal to the opposite over the hypotenuse. And in order to work out what theta is, which is the angle, we need to inverse sine both sides. So this will leave us with theta, because the inverse will cancel the sine out on the left-hand side, and on the right-hand side we'll have the inverse sine of the opposite over the hypotenuse. Okay, so this might seem a little bit confusing right now, but it will be a lot more clear when we start going through the questions. In the second triangle, we have been given the hypotenuse and the adjacent. For that, we need to use cos. Because that involves the hypotenuse and the adjacent. This means cos of theta is equal to the adjacent over the hypotenuse. We inverse cos both sides in order to find cos, leaving us with theta is equal to inverse cos adjacent over hypotenuse. The third triangle, we have been given the opposite and the adjacent. So we use tan because tan involves opposite and the adjacent. So tan of theta is equal to the opposite over the adjacent. We inverse tan both sides in order to get theta on its own. So theta is equal to inverse tan opposite over adjacent. Okay, so I would advise you to write all of this down because it will prove to be useful when we start going through the questions. You will notice that the question numbers are not consecutive and do not start from 1. This is simply because the questions refer to Cherry Hill specific material. But do not worry if you do not have access to this, as I will still cover the concepts in full. So question 14, we have a right angle triangle where we have been given two sides and we need to work out theta. So the first thing to do is to label this triangle. So the hypotenuse is the side opposite the right angle, and it's always the longest side. The opposite is the side that's opposite theta, and the adjacent is the base side. Now let's write down SOHCAHTOA, because we will need this. So what this means is sine theta is equal to opposite over hypotenuse, cos theta is equal to adjacent over hypotenuse, and tan theta is equal to opposite over adjacent. As you can see, we have been given the hypotenuse and the opposite. So try and think about which trig formula we will need to use if we have been given the opposite and the hypotenuse. Hopefully you will agree that we need to use sine because that involves opposite and hypotenuse. So sine theta is equal to the opposite, which is 8, over the hypotenuse, which is 9. Now what we need to do is inverse sine on both sides because we need to try and get theta on its own. So sine inverse of sine theta is equal to the inverse sine of 8 over 9. This leaves us with theta on the left-hand side and sine inverse 8 over 9 on the right-hand side. Now, if we plug this into our calculators, what we get is 62.73 degrees. Okay, and that's your answer. That's theta. So hopefully it is starting to make a little bit more sense. I would advise that you pause this video and try this question again on your own without looking at my working out to check if you get the same answer. Question 16, we have another right angle triangle and we need to work out theta. So the first thing to do is write down our formulas, SOHCAHTOA, and also label our triangle. So the hypotenuse is the side opposite the right angle, the opposite is the side opposite the theta angle, and the adjacent is the base angle. Okay, so we have been given the adjacent and the opposite. So I will give you 20 seconds to just work out which formula you think we will need to use. Hopefully you will agree that we need to use tan because it involves opposite and an adjacent. So tan of theta is equal to opposite, which is 5, over the adjacent, which is 6. So tan of theta is equal to 5 over 6. We now need to inverse tan on both sides in order to get rid of the tan, leaving us with only theta. The tans cancel out, leaving us with theta on the left-hand side. And then we have inverse tan 5 over 6, which will give us 39.81 degrees. And that's your answer. Okay, so I hope this is now starting to make a little bit more sense. Pause this video and try the question again on your own to check if your working out and answer matches mine. Question 18. So let's start by labeling our triangle. So the hypotenuse is the side opposite the right angle. The opposite is the side opposite the theta angle, and the adjacent is the base angle. So we have been given the hypotenuse and the opposite. Hopefully you will see that this means we'll need to use sine because it involves the opposite and the hypotenuse. So sine of theta is equal to the opposite, which is 2, over the hypotenuse, which is 12. We now need to inverse sine on both sides, leaving us with this. The sines cancel out, leaving us with theta. And then if we do the inverse of sine, brackets 2 over 12 in our calculators, we should get 9.59 degrees. Okay, so pause this video and try the question again on your own, and let's check if your working out and answer matches mine. Question 23, we have another right angle triangle. So we have the hypotenuse, the opposite, and the adjacent. We have been given the hypotenuse and the opposite. This means that we will need to use sine. So sine of theta is equal to the opposite, which is 10, over the hypotenuse, which is 20. We will then inverse sine on both sides, leaving us with this. On the left-hand side, the sines cancel out, leaving us with theta. And then if we put the inverse sine, 10 over 20, into our calculators, we should get 30 degrees. Okay? Thank you for tuning in. Remember, practice makes perfect. Never give up. I will see you in the next tutorial.